because they didn't really get this lesson the other day.
Rule number 7. Okay. It's the power rule for
Pay attention.
negative integers. And basically it's the same thing. If I take the derivative of x to the n with respect to x, that's going to be n times x to the n minus 1. Even if n and so what that looks like, though, is here's my function. F of x equals 1 over x. That doesn't look like anything that has a negative exponent, does it? It does. What is it, Ben, if I rewrite this?
X to the negative first.
That's x to the negative 1. So then if I want to take the derivative, f prime of x, that's equal to, bring the negative 1 down in front, right, Max? No. Times x raised to the negative 1 minus 1. What's negative 1 minus 1?
Negative 2.
Negative 2. So this is equal to negative 1 times x to the negative 2. But what's x to the negative 2?
1 over x squared.
It's 1 over x squared. So this is the same thing as negative 1 over x squared. Okay? So it's the same as the power rule. It doesn't change what you do. The process is still the same, but your result looks a little bit different. Okay? The negative 1 comes down in front, then you subtract 1 from the exponents. Okay? So that's rules 1, 2, 3, 4, and 7. All right? 1, 2, 3, 4, and 7. What about 5 and 6? 5 and 6 are the most important rules. Well, I shouldn't say that. 5 and 6 will be the hardest for you to remember. The power rules, and basically all of these kind of center around the power rule, the shortcut to finding derivatives. Rules 5 and 6 have to do with when you multiply two functions together. Okay? So rule number 6, or rule number 5.
It's because these rules are that important, they need to be done in purple.
And that's it exactly. The product rule. Okay? The product rule says that if I have two functions, if u and v are differentiable functions, then the derivative du times dv with respect to x. If I want to find the derivative of these two things multiplied together, that's equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. Otherwise, it can also be written like this: u times v prime plus v times u prime. Okay? Same thing. See how that's the same thing? Just another way to write a derivative. Derivative of v, derivative of u.
Will you show an example?
Yep.
Sweet.
Actually, I have two examples to show.
Even better.
Example number 1 you actually don't have to use the product rule for. But let's say we define f of x as, let's do 6x cubed times 7x to the 4. Okay? There's two functions, u and v. Now, just a side note, right? F of x is equal to 42 times x to the 7th, correct? Is that right? So really, if I wanted to find the derivative of f of x, 7 times 42, that's going to be 294. Is that right? 294 times x to the 6th. That's the derivative. Did I do that right? Help me out. 7 times 42.
Yep, that's what
Okay.
it looks like.
So that's what, if I apply the product rule here, I should get this for an answer, shouldn't I?
Yep.
So let's do the product rule. Here's my u, here's my v. And sometimes it helps when you're doing this, come off to the side and write u prime equals 18x squared. And v prime equals 28x cubed. Just off to the side. Now the derivative, f prime of x, is equal to u times v prime plus v times u prime. So go ahead, 6x cubed times v prime, which is 28x cubed, plus 7x to the 4th times 18x squared. 6 times 28 is going to give me 168 x to the 6th. 7 times 18 is going to give me
126.
26x cubed, or x to the 6th, excuse me. Add those together, and I'm hoping that equals 294.
It does.
Okay? So you see how this works. Right.
I was just wondering, so this is for u times, excuse me, u times v. What if it were u divided by v? Would it then be the same thing, but instead of plus, it's minus?
Guess what rule number 6 is?
What I just said?
The quotient rule.